Okay. So these were the steps that are being required for performing a hands-on related to the logistic regression, where first we'll be collecting the data, then second we'll be analyzing the data. So in analyzing the data, we'll be just trying to find out the relationship among the different variables that are existing into the data set. So once we analyze what kind of a relation exists between the different variables, we'll do the data pre-processing part and data cleaning part. And after that, it says that we'll divide the data set into the training and the testing one. And after splitting, so usually we do it sometimes at 70-30 ratio, sometimes we do it at a 80-20 ratio. So the training and testing are being done, and then various parameters are there for calculating the performance evaluation. So we'll, for the logistic regression especially, we'll be calculating the accuracy, precision, recall, and we'll also can see the confusion matrix in between in order to see the precision, recall, and accuracy for that. So this is the complete scenario or the pipeline that we usually require. So now there's one thing that logistic regression, we usually get inbuilt functions and we can simply do that as well. But today's session will be simulating an algorithm for a logistic regression. So we'll be demonstrating the steps for not using the inbuilt library. Despite of using the inbuilt library, we'll be coding for the logistic regression. Otherwise, if in case you would like to go and use the inbuilt function, you can do that as well into the Jupyter notebook. So for the hands-on, we'll be considering two particular things. The first one will be considering a breast cancer dataset, which I've downloaded from the Kaggle. And into the today's session, you will have to download the Titanic dataset, and you have to perform the same thing after you, once you are able to do it on the breast cancer dataset, you can just try it as an exercise onto the Titanic dataset as well. And we'll be using a Google Colab. So those who haven't signed up onto the Google Colab can just do it right now along with the hands-on session, and correspondingly can perform it. So I'll first of all simply explain the code, and then we'll open the code onto the Google Colab, and then we'll perform it. So the step one will be, we'll load and pre-process the data. So yeah, I already elaborated into my last session as well that what a Colab is. So Colab is a hosted Jupyter notebook service that requires no setup to use. So we just have a cloud-based service something, and our machine doesn't needs to be efficient enough in order to install set up this particular Colab. So it provides free access to the computing resources, including the GPUs and the TPUs. That is why we usually use a Google Colab, and it can be best suited to the machine learning application scenarios. It can do data science, and it can be used for the purpose of education as well. So it's not that I cannot teach onto a Google Colab. Along with the coding onto the Google Colab, I can put up my comments over there. I can paste up the pictures over there. So the Google Colab can be used for the purpose of the education as well. So now this is the first step where we'll load and pre-process the data. So the first thing is that is being required is importing the required libraries, and then followed by that we'll be loading the data set. Okay, so if you see this particular piece of command where it says import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT. So these are the necessary libraries that are being required in order to implement logistic regression, right? So these are some libraries that are already available into the Python, and we will import these particular libraries. So this, for example, the matplotlib is the library that will be used for the purpose of drawing a graph. So in the end, you will be showing a graph. So this particular thing will be used for showing a graph. Then we'll be using the sklearn as well. So we'll be from sklearn.datasets, we import the breast cancer dataset, and also we have from sklearn.preprocessing, we import the standard sklearn. So for the pre-processing thing, we'll be using a normalization method, and for using a normalization method, we'll be using a standard sklearn for that. Now the first thing is, once we finished importing the libraries, right? The next thing is to load the dataset. So now we'll have that data set as a CSV, for example. So this was the data set being named as breastcancer.csv. So we loaded the data set. So we took a variable data is equal to pd. read underscore CSV. So this is an inbuilt function there, read.csv, and we'll be reading the data from the particular CSV. So this breast cancer.csv is being downloaded from the Google, and we are trying to load the data set. Then x is equal to data and radius underscore mean. So I showed you two particular variables. The one was the target variable and another one was the radius mean variable. So if in case you don't remember, I'll just show you. Yeah. So this was the one. One was the radius mean and another one was the target. So our output is to diagnose whether the person is being suffering benign or malignant, is being diagnosed with either a benign or being diagnosed with a malignant during the breast cancer diagnosis. So that is why you consider the x is equal to data, radius underscore mean dot values. So then you'll try to reshape the data and you'll try to fix it between -1 and 1. So the data that was generally into CSV being considered as a two-dimensional data set, right, into one-dimensional vectors, or you can say tensors or data. So the reshape function will help you do that. So that is why what data you captured over there, these particular values are being reshaped to -1, between -1 and 1. Then y on the y-axis, so this is the x-axis. So onto the x-axis you are depicting this one, and onto the y-axis you are displaying the results of the diagnosis that can either be 0 or 1. So here what you have done is data diagnosis dot apply lambda x. So this is something like if the value is this one, right, then you map it to the true, and if the value is false, then you map it to this one. So you are simply trying to put the diagnosis as either 0 or 1. So where the 0 is meaning as benign and the 1 is being meant for the malignant. So here you just define this particular thing, and then you have a scalar and you use the standard scalar in order to pre-process and or normalize it. And then x underscore scaled is equal to scalar dot fit transform. So then you will transform the values using this particular function. So this is, you are completed the step number 1 where you are loading and pre-processing the data. So what you can do is you can, okay, I'll simultaneously show you. I'll open the Google Colab simultaneously and I'll show you that one. Okay. So from here, what you can do is you can type Google Colab. So if in case you have first to the Google Colab, so you first press this one, right? And then open a notebook. If there is an existing notebook, you can open that particular notebook. If in case you want to create a new notebook, you can do the new notebook with the help of this particular cursor at this particular place. You can even write a new notebook and you can start coding over there. The internet is little bit slow, that is why it is taking time. If the internet speed at your end is perfectly fine, then you can simply start generating the code over there. So here you simply start writing import pandas, import, right? So from this place onwards, you have to start writing this one, import pandas as p, and then import. So import the necessary libraries over here. So all the necessary libraries are to be imported at this particular place. So once you import it, and then you start writing the code for the for loading the data set as well. So all this you can do at this particular place. If in case you have an existing one, so from here, for example, I have already opened my existing one. So I already coded it as, so I'll show you import pandas as pd, numpy as this, import matplotlib plet as this, and then sklearn dot preprocessing. So I imported all this and then I loaded the dataset. So this stands for the comments. So you can write the comments over here and you can put this particular thing so that this defines that, okay, this one. So even if you run this one, it will show you an output, right? So Python usually doesn't have a compiler. Python usually have an interpreter. So you can simultaneously run your code as soon as you write it. So first, for example, importing, you will run it, then correspondingly you can send. So this is the command where you can run cell and below. So you can run using this one if you want to run this particular point of code, right? And in case you want to run the complete code at once, then you can simply use the run all option and you will be able to run it. Okay, so this is where you can write it, or also you can rename it. For example, this is the untitled. So despite of untitled 4, you can write it as test, right? So here you can name it as test, and then you can correspondingly do the necessary steps over there. So now, okay. So that's the first step you need to define. Then the step number 2 is, since we learned about that it shifts from the y is equal to mx plus c towards the sigmoid function. So I told you the formula for the probability, that was the sigma of z is equal to 1 plus 1 divided by 1 plus e to the power of minus z, right? So this was the sigmoid function. So the same sigmoid function is being defined over here. Def sigmoid z return 1 divided by 1 plus np.exp minus z. So that's the 1 plus e exponential of minus z. So that is being written over here. So we simply define the sigmoid activation function. Then we also define the binary cross entropy loss function. So the formula for the, so it's the summation. For example, what I explained was that while I'm having quantum options, okay, I'll use this one. So what I said was that, for example, this is why my y mx is equal to c, right? Sorry, it should be a very straight line. It should not be something a curved one. Since no, I'm not able to draw it. Let me try again. Since this is a pointer, I cannot draw a very complete straight line. But suppose this is a very straight line, y is equal to mx plus c, right? So what it says is that shifting from this particular linearity towards the sigmoid kind of a curve, then there is something called as, that you require this one. For example, this one, you want to deviate from the straight line towards the sigmoid curve. So this is what our basic target is, and this is what we are trying to do into this one. So we'll put the value of y is equal to mx plus c also at this particular place. Then I'll show you the step as well. So this is the loss. It says that the loss formula is this one. So this is not my generated formula. This has been picked up from the standard formula that is being picked up from the book. So you simply define the binary cross entropy loss, and you have some two parameters being passed on to it. Then m is equal to length of y. You calculated the length of y. Then return, this particular function is being implemented, and you simply write this function as it is at this particular place. So since this is being done, I'll show you this card. I'll show you simultaneously what is happening over there. Okay, so if you see here, so this is the place where we define the sigmoid function, return 1 by 1 plus e to power minus z, and we define the cross entropy function. So this is the formula for the cross entropy. So we define the cross entropy function. Now let us move to the step number 3. Okay, so this is the step number 3 where you define the gradient descent function. So this is, you have started training the model, right? So considering that you did the pre-processing part, and apart from normalizing, you took care of the null values, you took care of the outliers and other things. It seems that since we are considering that this data is already pre-processed, we just use the normalization method in order to normalize between some certain ranges. The rest we consider that it is, so we are not showing the implementation of the pre-processing over here. Whereas if in case your data is not clean, you need to first of all clean your data, right? After analyzing and trying to find out, since I was already aware of, okay, what is the relationship between the different variables, so I simply started coding the logistic regression algorithm. Whereas in actually when you have to do, you necessarily should first of all analyze the data, see what is the relationship between different variables, which particular features are important to you, and which particular, because the data set might be having 1,000, for example, 100 features, or the 100 columns you can say, right? So all the 100 columns need not go into the data set. It'll unnecessarily have loss into your either precision or recall or these particular things. So do not pass on all the features to it. Only try to find out a relationship, right, with your target variable, and then see which of the features are, for example, if I consider a simple feature, for example, patient ID, right? So the patient ID is not something that will be of relation, putting up any relationship with this one, right? So patient ID may not be given as further passed on as a feature. If in case I want to try to diagnose, okay, the how many percentage of people are belonging to a Bennington and how many percentage, until and unless I require, give me the IDs of those whose probability is, then only I'll pass this particular ID as the particular feature to be transferred. Otherwise, ID may not be, if you simply want to state that, okay, how many people are being classified under the Bennington or how many are being classified. But I would also like to tell you that sometimes the PID which I was referring to, right, may be something related to a privacy concern. So usually you can get an anonymized data where the demographic details of that particular person into a healthcare are usually not being passed on. But at times, if the data is, for example, a synthetic data or being picked up from a Google, may not be an anonymized one. So after that, you'll do this particular thing. So the gradient descent function to optimize the weights. So you'll do the optimization of the weights using the gradient descent function. So you can also use a version of the gradient descent version as a function over here. So def gradient descent, and then you passed on x, y. You just define the learning rate as 0.1 and you put the number of iterations as 1000. So this is another point of concern, that how much to put an iteration and what should be the learning rate, right? So that's a point of concern. But here the iterations has been made as 1000 depending upon that total entries that were available into a data set were these ones. So that is why the 1000 iterations are being performed onto this one, and the learning rate was being defined as 0.01. Now we calculated the length of y. Then since I showed you the function for the gradient loss at this one, then there's another function for finding it out, the theta, and then so this is we are performing the training of the model. So theta is equal to np dot zeros x dot shape 1 plus 1, this one. So we are just initializing the weights, and we initialize all the weights including the bias term is there. Then we add a bias term to the x using the this particular equation, x underscore b is equal to np dot c, np dot 1 x dot shape 0, 1 and x. Then loss history is being defined over here. Then we run it for that particular number of iterations. So for I in the range, then it says that z is equal to x underscore b dot theta, and then you have a sigmoid over here. Then after calculating the predictions, you compute the gradients. So the gradients are being computed using this particular formula. Gradient is equal to 1 by m cross x underscore b dot t dot this y underscore hat minus y dot reshape minus 1 to 1. So then you update the weights. So theta is equal to theta minus learning rate into gradients. So right, so we simply, despite of writing theta is equal to theta minus learning rate into gradients, we simply put this particular symbol over here, which implied into the Python that it is theta is equal to theta minus learning rate into gradients. Then finally we compute the loss. Loss is equal to binary underscore cross entropy underscore loss, and then loss underscore history dot append loss. So then this particular gradient descent function is returning theta as well as it is returning a loss history. Now you train the model using the gradient descent function, which you defined into the previous step for optimizing the weights, and the bias is also being displayed. So theta underscore optimized, that was being returned from the gradient descent function, and loss history is equal to gradient descent x scale dot y. Now you print the optimized parameters. So you have the theta is equal to 0 intercept, theta underscore 1 slope, and you print the optimized theta as theta optimized. So once you print it, now the point here is that before plotting, you can divide it into a training and a testing data set as well, right? So whenever we'll be using the already defined functions, we'll simply put the 70-30 as the training and the testing, right? So here, since we just implemented a gradient descent algorithm, we are not showing it. But when you call an inbuilt library of a logistic regression function, you can simply put how much you are using for splitting the data set. Now, finally, we plot the decision boundary. So after training, we can plot the decision boundary, and finally, we can even do the calculation of the accuracy confusion store as well. So x underscore values is equal to np dot line space min and max of x scale and reshape minus 1. Then we add the bias term to it. Then y underscore values, we use the sigmoid function, and we use now the sigmoid function for the theta optimized one, right? And then we plot the graph. So we simply labeled it, which color do we want for the, and what is being plotted onto the x-axis was already defined, and then what was being plotted onto the y-axis was also being defined. So here he is simply writing it that represent this by the blue color, represent this by the red color, and then radius underscore mean standardized is being depicted, diagnosis as either benign or malignant is being depicted onto the y-axis. Then you plot what the values you are getting, the predicted values you are getting, and then you simply put the title as this one, and plot show will be showing you this one. So if you simply see, this was being referred to with the blue color data points, and this red was being referred to as a decision boundary. So here is simply a sigmoid kind of a curve that is being shown over here. So these were the data points that are being shown onto the x-axis. We just considered that it may be from minus infinity to infinity. So we just had minus 2, minus 1, 0, 1, 2, 3, 4. Right? Since we shaped the values to these particular, we mapped the values to these ones. And then onto the y-axis, we just diagnosed it as either belonging to benign. So this is benign and this is malignant. So these main data points are coming for this one, and these main data points are coming for this one. Right? So then this you can see to it as, and these are some of the references. Also, I can show you to the Google Cola. Yeah. So here into the Google, yeah, one thing I missed that, okay, when I had defined it as this particular place, that pd dot read underscore csv, right? So here, there's one thing. So from here, okay. Then let me try to run it and see if in case the code is there or not. It will take some time for you. If your net is slow, it will take some time, and this particular connecting option will be coming over there. And in the at the bottom, you can see connecting to Python 3 Google Compute Engine backend. So it means that it is trying to run. So just wait till your code is being compiled. Okay, so so you can join from there. You join. Okay. Okay, since the data set is removed, since I uploaded it, okay, I'll upload the data set. So it's the data set. You can use the sample data that was available over here, and you can analyze that data as well. So, but here from this one, you have to upload, since we are doing it on a breast cancer data set. So then once it will be uploaded, let me see. Then I have to run all again. One thing to remember, when your session is started, right? And when you simply exit it, your session end up. And then that particular, you will not be able to come again and run the same code, and the same thing will be performed. So the breast cancer.csv, I tried uploading it yesterday, but when I'm trying to do it and illustrate it to you, that is why it was generating an error. So if in case you will be seeing it here, it is not generating an error, and this is the particular thing is being running, and this is the exact thing what we are expecting. Okay. So once I terminate this particular session, this particular data set I need to upload. So every time I need to start a session, I need to upload this particular thing. Now, one of my scholars is there, Tushar. He'll help you. So you can start exercising it, and Tushar will be able to help you out for if in case you have some doubts or something. Tushar will be able to help you out. Tushar, you are there now? Tushar, are you there? I'm not able to. So, Professor Surendra, can you please give the rights to him? Tushar is
Okay,
there.
ma'am. Yes, ma'am. Yes, ma'am.
Okay, Tushar, you can join.
He may be the attendees, so I
Tushar,
will
please.
make it.
Yeah. Tushar, please share into the chat box the code so that they can reuse the same code, and once they'll implement it, they can please share the data set. Data set I'm sharing, you share the code onto the chat box. Okay, I cannot copy. So, Professor Surendra, how should I share it? Should I send and you'll be able to, because into the chat box, I'm not able to share the data set.
Ma'am, just you make a copy and just paste here in the chat box. So I made Tushar as a panelist. So
I'm trying to paste it over here, but then I don't think so. I'm able to share it into the chat box. Webinar, I don't think so. This is not permitting me to share
okay,
it.
maybe you if possible you can paste in the WhatsApp group. I will share to the participants.
Okay. Yeah, that would be an option. I'll share onto the WhatsApp.
Tushara, am I audible to you?
Yes, sir.
Okay, fine.
Hello. Yeah.
Yes.
Can I start?
No, Tushar, if somebody has some problem, I have shared it on to share with sir. Sir will share it with the participants. If in case there is some problem, you can just help them out.
Yes.
Yes, ma'am. Actually, I shared in the WhatsApp group of participants WhatsApp group.
I've shared the link to the data set as well. So please
Okay, ma'am.
forward.
Yes, ma'am. Done, ma'am.
Yeah, please. I'm here only in case of any doubts, you people can ask either Tushar or me.
Hello, participants. Please, you do as per the instruction of ma'am. Just you download this data set from the Kaggle, and IPYNB file is already in your WhatsApp group. Just you run it and run each cell, and just if you have some doubt, any issue, just you can ask here in the chat box. Okay, ma'am. So we will give 5 to 10 minute time to just run the code to the participants. So meantime, if they are having some maybe suppose doubt is there, then we will just solve the query.
Okay, 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 perfect, sir.
So participants, I request you please just you run the code, run the cell, and if you have some doubt error is coming in this Python code, just you ask to the ma'am or Tushar. Hello, participants. If you don't have any doubt, then please type in the chat box clear. Okay, fine. Drive permission. Okay, actually, I sent the file in the WhatsApp group. So the one procedure is, yes, access denied. So just you download the IPYNB file. Okay, and once you open the Google Colab, then upload the same file. There is a one option, upload. So I repeat again, please you first download the file, IPYNB file. Download this IPYNB file and open the Google Colab. Okay. So Google Colab, just you type this Google Colab in this Google search engine. And open the first link. So once it is open, then in the file option, you will find another option, upload. And now you run the each and every block. Dr. Priya, now you run each and every block and check line by line. So I hope the procedure is clear to you, how to upload and download this IPYNB file. You have to just run the each and every block and check the code. Now is it okay, Dr. Priya? Okay,
Download
fine.
it and
For Google Colab, you just open a browser, simply type Google Colab, and then click onto the first link of the Google Colab and just link it with your Gmail account. Sorry, my internet from that particular place got disconnected. So I'm from Tushar's laptop.
So I hope everything is fine from the participant side.
I also hope so, Professor Surendra.
To link with Gmail, what? See, uh, just you sign up in the Gmail account, whatever your official or maybe any your personal Gmail account. Just you first sign in. Okay.
Yes, yes, yes. Jyoti, you please sign in.
Okay, fine, fine.
But you on to the leftmost side, see a rectangle kind of a thing. So I'll show you from where you can upload the data. Okay. From where to upload the Google Colab, from where we uploaded
I have
data.
to share my screen.
Yes. So we are sharing our screen. Simply please reloop to it. We'll again show from where to upload the data set.
So then this is how your Google Colab environment looks. You have to come on the file section that's placed on the left hand side. Click on files and then you have an upload file option here. So you click on this file and wherever you have downloaded your dataset, you click on that and open it. It gets uploaded into your Google Colab environment. So once you've done uploading the dataset, you can run all cells and your output will be shown after every cell.
Upload. Just hold on. No,
You have to download the CSV as a zip file from Kaggle first, and then you have to unzip the file and then upload it to Google Colab.
So participants, please you do by yourself. And if you are having some doubt, then again tomorrow, ma'am, uh, that will come again for next topic. So at that time, you may ask your doubt tomorrow.
Dr. Kalaipriya ma'am, please could you rerun all your cells once again from the starting? Please rerun your cells. Okay, sir. Now next cell error. Okay. Ma'am, could you please tell what's the error?
Let me start this first. Just saw this, take this, and then tell them that we do it.
Why bread? Ma'am, please see my screen. Go to runtime, restart session and run all. Click on restart session and run all.
This is good. Okay, participants. So, if in case you have some certain doubts, we'll be taking it to during tomorrow's session. Thank you so much. Thank you, Professor Surendra. Okay, so we'll disconnect.
Okay, okay, ma'am.
Okay, sir. Okay.
Okay, participants, you keep your doubt uh, as such, and you can ask your doubt in a tomorrow session. Okay, again, Dr. Shelly Sachdeva ma'am, that will be with us tomorrow, the same time, 11 o'clock. And after lunch session, she will be having another lab session. So at that time, you may ask your doubt. Okay. So shall we take a 5-minute break and we will start the next session at 3:10? Okay.